Hi all. In this video, we'll talk about assignment 7, which is based on the concept recursion. So, yeah. So the main idea of this assignment is to get you familiarized with what recursion means and how to implement recursion and how do we solve smaller problems using recursion and see it at a bigger, broader level using the concept of inception film. And though it doesn't have much to do with dreams and all we are trying to do is to see how we recursively allocate dynamic memory and how we deallocate it. So, uh, mimicking the movie Inception, we have two classes. First class is character, where it represents the character Don Cobbs, where he'll be recursively dreaming. And there is another class in the handout, which is for um, dream, like generating each dream. So now, given these two classes were provided in the form of header files. Your job is to implement both the classes and create separate files, character implementation.c++ as well as dream implementation.c++. So all the functions and the member variables for each class are provided here. Now, let's get started with the character class. So the like I said, we'll be exploring the concept of recursion, but through smaller problems. So the first smaller problem is read from file. So let me talk about read from file. So this function, it doesn't have a return type. It doesn't have a return type. So it's void. And this is the name of the function, read from file. Now, the agenda of this function is it has to read recursively from a file. So far we have been writing loops to read data from a file, but this is like first-hand introduction to how do we read data from a file using the concept of recursion. And there's a catch here. When we are reading data recursively from a file, we want to read the data in bottom to top approach. So bottom to top approach. So the idea is that whatever is the last command in the file or last line in the input file, that should be the first command. So, and when I say command, I'll give you a brief introduction of what I'm talking about. So we have an input file called commands, commands1 or commands2. If you see each file, like if you see each line is a string, there is no space separation, it's a string. So you should be reading each of these lines into a string variable, and eventually you are required to store all these lines into a vector of strings, which is part of the class character. So if you see, we have something called as commands. Commands is a vector of strings. So the idea is that given an input file, you have to read all the lines in this input file into a vector of strings. Each line is a string, or each line is an element inside the vector. But the only catch is here is that we are reading from bottom to top approach. So the last line in the input file should be the first element in the vector of strings. So that's the catch. What we mean by bottom to top approach is the last line in commands file is the first element in the vector of strings. So commands is a variable for that. And this commands is a vector of strings. So that's the first part that we're going to implement. So whenever we talk about recursion, we talk about two things. What is the base case? Like when exactly does a recursion stop? So the only possible base case for reading data from a file would be keep reading until you reach the end. So the base case is something that you have been writing like a lot of times throughout 135 and 202. So for this function, whatever the base case is there, base case is when you reach end of file, or when you are done reading last line from the file. So that's the base case. And then the recursive case, keep calling the function. So it's the same function. So recursion means function calling itself. Keep calling the function and adding each line into the vector called commands. So adding each line into the vector. And the name of the vector is commands. So simple task. You have to read each line, but in bottom to top approach from the file, and store it into a vector. And for reading the file, we already have a file stream object as part of the class. And if you see the parameterized constructor, it's already accepting string file name. So as part of the constructor, you're supposed to open the file. And as part of read from file, remember, it doesn't return anything. It's void type. It doesn't take any parameters. So it's like void function with no parameters. Now you have to call this function recursively. The base case is that have we reached the end of file, or have we read the last command from the file? And the recursive case is that keep calling the function, and then whatever the line that you have read from the file recently, push it into the vector. And the vector is also a member of the class. So these are the two things that we are supposed to take care in this function. And then we have another function called print commands. The print commands function, it doesn't have much to do. All we are supposed to do is to go through the vector that we have read in and print each command that we have read in from the file. So all you would be needing to do is to write a loop and traverse through the loop. And coming to reverse string. So this function is again another recursive function. So this is the second recursive function that we have in the character class. And it is called as reverse string. So the idea of this function is that given a string, hello, we want to call the function reverse string, and we'll be supplementing this function with the current string that we have and some other parameters. And this function should give back, the string in reverse order. So this is what it should give back. So given a string, this function should return back the reverse of the string. And if you see, we have like command, which is taking the current command that's being read from the vector. And then we have reverse command. This is the parameter into which you're supposed to write the reversed string. So we'll be building character by character. And if you see the description here, that says that like what all needs to be done as part of reverse command, it's given exactly here. We have we have captured both the base cases and recursive case. So ideally, the logic goes in this manner. Identify the last index of the string. So for example, for the string hello, this is how it gets stored internally. These are the indices, and this is the last index, and this is what will be the value of index parameter. So if you see, one of the parameters is index, and at the beginning, let's say if command parameter is hello, and at the beginning, we'll take a reverse command, which is like an empty string, but eventually we'll build it up as we run the recursive function. So it's an empty string at the beginning. Now, our goal is that we have to go back in the reverse direction, and we have to stop when we reach the 0th index. So again, think of this way. When are we going to stop the recursive function? That means what is the base case logic The base case logic is simple. When the index value reaches 0, that means we are done, and that's when we are going to return back from the function. And in the recursive case, all we have to do is keep calling the function, reverse commands, reverse string, and you'll be passing the command value anyway, which is like not modified, which is not modified anyway in the recursive function. But the reverse command, it needs to be modified, and you will be storing each character by character into this reverse command as you call the function recursively. And eventually you have something called as index, and you will reduce index by 1 whenever we call this. So whenever we are calling the, sorry, this is not a recurse string, it is reverse string. Whenever we call this function recursively, we reduce index by 1, so that we move from last index value subsequently by one character towards the left hand side. As we are moving one character by one character towards the left hand side, we want to update our reverse command by doing something like reverse command plus is equal to whatever the index that we have, that we'll be storing into it. So this is going to be the index. So this is how we update reverse command and eventually ensure that we have a string that's being returned in reverse order. So that's pretty much about what, the second recursive function. And the third recursive function, I'm not going to go in detail, but this recursive function asks you to implement the Fibonacci series. So given an integer value, you have to return the nth Fibonacci number. So just to, I'll just give a brief overview. This is a third function, and this is about Fibonacci numbers. So Fibonacci numbers typically follow this order. So whatever the last or most recent two numbers are, sum them up and you'll get the next number. So sum the most recent two, you'll get the next number, sum the most recent two, and so on. So this is what we call as first Fibonacci number, second number, third, and so on. So given n, like let's say if n is 1, you have to return the first Fibonacci number. If n is 10, you have to return the 10th Fibonacci number. So that's what you need to do here. So this is the third recursive function. And the start dreaming function, this is the fourth recursive function. So again, this function is an example for, it doesn't have a return type. It doesn't accept any parameters, but still it's a recursive function doing certain tasks. So the first task is that like we have a third member variable for this class, which is current index, which helps us in pointing out like where exactly are we in, like if I'm reading 10 commands from the file, am I now parsing the first command or the second command or the third command? This is the variable that tells me like, which command am I parsing right now. So, and then, like I said, like this is a function that kind of mimics Inception film. So where we start dreaming. So we'll, call this function once. That's the first level of dream. And then it recursively calls itself. So it's like a dream inside a dream and so on. So that's the best analogy that I could find, though the assignment may sound silly, but that's something that I wanted to, connect between recursion and dream inside a dream inside a dream, a function call inside a function call, and so on. And the objective of this function is that we are reading commands from the file. And at the same time, we also have something to do with reversing a command. We also have a Fibonacci number and so on. So the key takeaway of this function is that as we read commands from the file, if we encounter a palindrome, so a palindrome is something like if you read it from forward or backward, it has the same, it means the same thing. So if we encounter a palindrome, palindrome command, then stop dreaming. So this is the base case condition for this function. There's another base case condition. So this function has like two base cases. Either if we encounter a palindrome, or if we reach the end of all commands. So either if we run out of all the commands, or if we found a command that's like the, what do I say, like the palindrome command. So in either of these situations, we'll be asking the character to stop dreaming. So that's pretty much about it. And now the catch here is that while we are dreaming, the recursive part, or while the character is dreaming, we need to create a dream object. So you need to take something like a dream pointer or something and dynamically create a dream object. Now, let's look at dream object. So like in the Inception film, whenever Leo is dreaming or taking others into a dream, he builds the environment for the dream. So here also we use the dream class to create the environment. And when we say environment, all we are doing is we are creating a dynamic array of integers, and we'll be having something like a dream level. So if you go through the constructor and the dream function, if you go through the constructor and destructor, this should be the destructor. Apologies for the typo. There should be a tilde before it. So if you go through these descriptions, they will be like self-explanatory. We'll be allocating dynamic memory, and we'll be deleting the dynamic memory as we call the destructor. And now the idea is that whenever you are creating dream object, you're asked to create a dynamic array. So the catch here is that if you are in dream level 1, so if it's like dream level 1, then the dynamic array should be of size first Fibonacci number. So whatever the dynamic array is there, its size should be first Fibonacci number. And as you recurse the function, let's say if you are at a dream level of, let's say 5, then the size of the dynamic array should be the fifth Fibonacci number. So this is where we are using the Fibonacci number concept. As you call this function start dreaming recursively, you have to keep track of something called as dream level. So you can go through the start dreaming function where we have like a complete description on what should happen at each case. So you'll be checking for the palindrome. If the command happens to be a palindrome, that's when you stop the recursive function calls and return back. Or if we run out of all the commands, that's when we stop. So there are two conditions for it. And recursive call, here we have the criteria and the backtracking part. This part is where we dynamically call the delete the object that we have created, and that calls the destructor in turn. But the overall takeaway is that like there are two cases. Start dreaming, for the start dreaming function, we have a recursive function. This is a condition where the recursion should stop, or when the recursion should stop. Or in the other case, when we are recursing through this function, all we have to do is like create a dream object. And remember, dream object takes two parameters: number of elements, like what should be the number of elements in the dynamic array, and what all should we use it to be populated with. So I have both the descriptions here: dynamically allocate number of elements, and then what should be the value. And here inside the function start dreaming, I've given the values for what should be these are for. So both of these, like the number of elements should be Fibonacci of dream level, and value should be dream level. So as you keep track, let's say if it's first dream level, the dynamic memory will be something like this: a pointer to a single element, and this element will contain 1 because it's dream level 1. If you are in fifth dream level, and if you observe, the fifth Fibonacci number, fourth is 5. So that means you will be creating an array with 5 elements, and you will be populating it with 5 because it's fifth dream level. So in this way, we kind of work with recursion and mimic something similar to an inception film, though it's a silly scenario that we are implementing. But overall, the takeaway is that, like, how do you do a task that you have been doing in the straightforward way with recursion? And the catch here is that, like, whatever the work that we are doing, what happens if we do it right in front of the recursive function call, or what happens if we do it after the recursive function call? That is there to give you a glimpse through read from a file in a reverse order, bottom up approach. And reversing a string, this is an example to show you like how we can use recursion to reverse a string. And the classical example, Fibonacci series. How do we add up the most recent two numbers to get the next number? And start dreaming. This is a function that helps you to get some insights into like what happens if we recursively call or create an object where dynamic memory is being allocated, and how do we free those resources as we come out of the recursive function calls. So all these four functions are kind of straightforward. You can go through them and give all these a try. And the last part, again, for the character destructor, I've missed the tilde sign. I'll correct these two things and re-upload the PDF. But this should be the destructor. And here we'll be simply closing the file. So yeah, that's pretty much all I have for this assignment. And kindly reach out to the TAs or your instructors in case if you have any questions. Thank you.